Hello, this is John from caveofprogramming.com. In this tutorial we're going to look at 3 more primitive types in C++. We've already seen a bunch of integer types and some floating point types, and we're going to finish off this little section by looking at 3 more very useful types. Well, 2 more very useful types and one that you don't really use that often, or at least I haven't, but that you should know about anyway. So the first type we're going to look at is Bool. Bool is named after a guy who I think his name was George Bool or something like that, and he was a mathematician who did a lot of work with logic. And the Boolean type, which has this keyword bool to represent it, can store either true or false. Let's type b value and we can set that either to true or to false. And if we output it, we get a little surprise. Let's try this with cout. What we get is we get 1, and that's because in C++ 0 is equivalent to false and 1 is equivalent to true. So we can also set this to false. Let's run that and we get 0. So 0 is the same as false, 1 is the same as true. You can actually put stuff like numbers in there and it will accept it and it will regard that as equivalent to true. So it's outputting 1. But don't do that because it's really confusing, so it's best not to do that. It's best to stick to true and false, but it is quite common in C++ to have something that evaluates to 0 or 1 and to regard that as being equivalent to true or false. We're going to take a bit more of a look at Boolean values later on when we look at complex conditions in C++. But for now I just wanted to mention this. So bool is a type that you can set to true or false basically. And by the way, it's possible in some compilers you might have to put bool and true and false all in capital letters to get it to work. That used to be the case in Visual C++, but I don't think it's the case anymore as far as I know. So another type I want to show you is char. And char it takes up exactly 1 byte of computer memory. So it's often useful just for that reason. If you want to allocate a specific number of bytes, let's type c value equals, and let's set this to 55. I want to show you something that at first appears totally perplexing here. Let's do cout c value endler, and if we run this, so we put 55 in it, what we actually get is 7. Now, why is that? Well, char is kind of partly intended to represent single characters from something called the ASCII character set. So let's go to a browser here and let's type in ASCII. That should do it, ASCII, and we'll go to this ASCII table link, or we could go to Wikipedia. It doesn't really matter. Let's see what's at this link here. And we can see that, a byte can only represent 255 distinct values. We see here we've got a table of, this is a table of, by the looks of it, 127 different values. So those are like, plus we've got another bunch of weird characters here, up to 255. So each character that's commonly used in the Latin alphabet, like in American English or something, plus a bunch of other characters that are quite often used, have a position in this table. And if you output a char with cout, for example, if we put the number 55 in a char, we see that 55, that is the number that's used to represent the character 7. So not the number 7, but the actual character 7. So what's happening here is that we're putting 55 into it, the number 55, and it's outputting the character 7. So it's very common to actually put characters directly in here, although it is actually an integer type. And to get the actual ASCII value of a character in C++, the actual number of that character in the ASCII table. I'm not sure what ASCII stands for, I can never remember. American Standard Code for Information Exchange. There you go. Then what you do is, so we put the actual character in single quotes. So if I type 2 single quotes here and put 7 in there, and then I run this program, it's going to output 7. So it's really important to realize here that a 7 in single quotes is not the same as the number 7. This number 7 is literally a number. If we put it in single quotes like this, it's a character. It's a symbol that happens to have position 55 in the ASCII table. If we actually want to see the actual number of the actual position of this character in the ASCII table, we can put int here in cout just before C value. This is called casting. We say that we're casting a char here, to an int, and that will cause cout to output this as though it wasn't an integer. So if you run this now, we'll get 55 again. So you can put any character that's in the ASCII table, basically anything from the American alphabet plus a load of other characters. Let's put G in there, into a char. And you can store numbers in a char, but you have to be aware. Let's just get rid of this int so that we can actually see the G, because that's a bit less confusing. It says G. But a char, you have to be aware, only can store a number. It can be minus 128 up to plus 127. That's 256 different values if you include 0. So 256, that's right, isn't it? I think so. Yeah, okay. So let's output the size of a char, because as I say, the size of a char is particularly important because you often use it to allocate a certain number of bytes in memory. Size of char. Let's try this and run that so we get it to build. Oh, we've got an error. What did I do wrong? So I've said, whoops, I should have put C out there, not char. Let's run this. So when it builds, the error goes away. So size of char is 1 byte, in other words, 8 bits. So you can only represent quite small numbers in that, from minus 128 to plus 127. One other type that I want to just show you is wchar_t, which is a very strange name. And this is intended actually for representing a greater range of characters than you can represent in char. So it's sometimes useful for that. But again, you could put you could assign it to a character like that. Let's output this and just see what we get. Endler. So I've never had to use wchar_t much, but it exists if you need it. So again, we've got an error because for some reason I typed the wrong thing there. It should be cout. There we go. So we're getting the position of I guess within the ASCII table here, but we could actually typecast I to a char. We could cast it to a char, and then we'll actually get I. But you can store more characters in wchar_t because it's the size of it's bigger than a char than you could in a char. So it's sometimes useful, I guess, if you're dealing with Unicode much and stuff like that. That's right here, wchar_t. So I'm going to run this, and there we go. It's actually taking up 4 bytes in the computer's memory. So to practice this, I'd recommend declaring some Boolean variables. Try setting them to true, false, 0 and 1, just because the act of typing it out will help to fix that in your mind. Declare some char variables. Try setting them to numbers as well as characters, and see what happens if you try to put a large number in a char, more than 127, and you'll see what kind of problems you get there. You'll get gobbledygook if you go over 127, or you have a number that's less than minus 128. and just declare a wchart, try outputting it. Try changing what cout displays with char or with wchart by adding that typecast to a char or an int in front of these values and see how that affects the output. I'd recommend just trying all these things, just because it will help to fix it in your memory, and we're going to be using, no doubt, Bool and Char later on. Probably not wchart because it's just not so commonly used. So that's it for this tutorial, and until next time, happy coding.